Q of the day. A 62-year-old man comes with a history of chronic kidney disease to the emergency department with weakness and palpitation. So these are the symptoms. For the past 2 hours, his medication include spironolactone and lisinopril, and he has a high heart rate, high BP, respirations all right. And this is where the gist is. The ECG reveals peak T waves and widened QRS complex. Laboratory results are pending. What is going to be the initial management? And let's see the options. Administer oral sodium polystyrene sulfate. I don't even know what that is. Hemodialysis. There's no need to start hemodialysis here. Even though he has a history of chronic kidney disease, I don't think it is because of the there's no need to start hemodialysis right now. And sodium bicarbonate, no. And this is the right answer. Administer him the intravenous calcium gluconate. And why is this the right answer? The gist and the catch is here in the peak T waves and widened QRS complex. This is where the examiner has given the clue. So basically this patient has got, what do you call, hyperkalemia. All right, so this patient has hyperkalemia, and the ECG findings of hyperkalemia that you need to know. The ECG findings of hyperkalemia are the first finding in the first stage of hyperkalemia. There is a peaked T waves and wide QRS with and it's going to appear and a little bit of a depression also, like this. And as the hyperkalemia progresses, there is going to be something called as sine wave pattern, where the ECG is going to be like this in a sine wave. Third is asystole, where the you don't see ECG, you see a flat line, and it will cause cardiac arrest. So why this patient has got hyperkalemia? Because he has CKD. CKD makes you prone to developing hyperkalemia. Now why hyperkalemia has this effects on the heart? See, potassium causes something called as repolarization of heart muscles. That's what potassium is going to cause. So what do we mean by repolarization? It basically means that it makes the heart muscles cell more negative and unable to contract. So now the heart muscle is not being able to contract, so it won't be able to function properly, contract properly, and this causes this thing arrhythmia, and eventually it will lead to cardiac arrest. So the treatment of this thing is calcium gluconate, and calcium gluconate is going to be the primary treatment. What does calcium gluconate do? It's going to stabilize the repolarized heart membrane, myocyte membrane, and it will decrease the repolarization. And you also, by the way, this can also be the second best choice, where you administer insulin and glucose. What do insulin and glucose do? You give calcium gluconate, but with calcium gluconate you should also start insulin and glucose. What that is going to do is it is going to push the potassium, whatever free potassium is roaming in the body, it is going to push that potassium back into the cells, because when you give insulin and glucose, insulin is going to make glucose go inside the cell, and see, once glucose go inside the cell, along with glucose, potassium will also go inside the cell. So overall, outside the cell, the potassium is going to get decreased. So this is what is the treatment of hyperkalemia